Hi, I'm Joseph Komorowski. Welcome back. I'm your professor. We're going to be going over Chapter 1 still, Section 1.4, and this time it's 1.4b. Last time we did truth, validity, and soundness, and we were talking about deductive arguments. In the second half of this section 1.4, we're going to talk about truth, strength, and cogency now in inductive arguments. So just as a quick review, you've seen this handout before. So notice last time we did deductive, true, valid, sound. Now we're doing true, strong, cogent. And notice the characteristic indicator words in these arguments: probable, improbable, plausible, likely, unlikely, reasonable. Whereas deductive, all or nothing, 100%, these are going to happen conclusions. These are more likely, probable, so it's in degree. So the premises provide only probabilistic support for the conclusion. If the premises are true and the argument's strong, probabilistic support. Whereas deductive, necessary support. Okay, so just a review of that little cheat sheet that you had. We'll get out of there. And then we go back. So again, now we're in the inductive part. And this will go a little bit faster today because it's very similar to the last lecture you had on deductive arguments. So here's one. Here's an example Hurley gives us. All dinosaur bones discovered to this day have been at least 50 million years old. Therefore, probably the next dinosaur born to be found will be at least 50 million years old. So if we grant the premise true, would the conclusion probably follow? Yeah. So it's not 100% certain, but yep, more likely, probably. And inductive arguments are really used as a backbone of the scientific method, because science, it's not 100% certain. There's a lot of hypotheses that test. They're probable. They're more likely to happen. They have confidence levels that are very high. There's a word called verisimilitude or verisimilitudinal, and it's the closest approximate truth. Notice it's not 100% true, but it's closest or the closest approximate truth. And again, if a scientific theory has revision or it's replaced by another theory, science allows for that correction because, again, it's not 100% true or false, but it's more likely or it's probably true. So science, you might say, has more flexibility. And give this an example. Dom Perignon champagne, which is made in France, sells for over $100 per bottle. Marquise de la Tour is also French champagne. Therefore, probably it too sells for over $100 per bottle. So if you were to grant this premise is true, would the conclusion probably follow? It turns out, we'll read down here, this argument, the premises, they are actually true. But our background experience tells us that the mere fact that the two wines come from the same county does not imply that they sell for the same price. So what this suggests is that the argument's weak. Now what that means is even though the premises are true, the conclusion doesn't really follow. Okay, so it's a weak argument, and therefore it's uncogent. How do we know that? So down here, right here. For a cogent argument, remember, just like deductive, where there's soundness, you had to have validity and true premises. The inductive arguments, in order for it to be cogent, it has to be strong plus true premises. We just saw the example of the wines. Even though the premises are true, it's weak. Therefore, the whole thing's uncogent. Remember, you have to have both conditions. And in the wine example we just saw, we had one condition, but we did not have the other one. The argument was weak. And what that meant was, just to reiterate one more time, even though you grant both premises true, the conclusion does not follow. And that just means it's weak. Okay, so you can look at the other examples up above. It says these four examples show that in general the strength or weakness of an inductive argument results not from the actual truth or falsity of the premises and conclusion, but the probabilistic support that the premises give to the conclusion. In other words, if the premises were true, would the conclusion probably follow? And that's what you really want to ask. So that's what makes it different from deductive. And then we have a chart down here. Similar to the last one we saw on deductive, on this side, all strong arguments. On this side, all weak. You can go down, and they exhaust all possibilities. You have a true premise, probably true conclusion, true premise, probably false conclusion, none exist, and on and on. So you'll notice one pattern. In all the strong arguments, you at least have the word every or all. You will see patterns of this. It just means strong language. And then over here in the weak, you say a few. So every, a few. So what it's telling you, so we'll look at this example. Every previous U.S. president was older than 40. Every one, right? Therefore, probably the next one or the next U.S. president will probably be older than 40. Okay, yeah, if I grant that premise, that seems to be probably true because, again, every president that was previous was over 40. This one just says a few U.S. presidents were lawyers. Therefore, probably the next U.S. president will be older than 40. First of all, we're talking about lawyers here, and here we're talking about age. That totally is a disconnect. So you can run through these examples. Now, again, when you're testing for strength or weakness here, you want to grant that the premise is true, or premise or premises, and then you want to ask, if it was true, would the conclusion probably follow? If it seems like it would follow, it's strong. If it doesn't, it's weak. So then he gives you an example here. He says, before proceeding further, however, we must qualify and explain this last statement. When we speak of the premises being true, we mean true in a complete sense. The premises must not exclude or overlook some crucial piece of evidence that undermines the stated premises and require a different conclusion. It's called the total evidence requirement. It just means, hey, when we're looking at any inductive argument and we think it's strong, we just want to ask ourselves, is there a piece of evidence that might be missing? And if there is something that might be missing, it flags as total evidence requirement. It's different from deductive because it considers the whole background of possible evidence that you might have. It just says, look, we're hoping that we don't have any other key pieces of evidence missing here. And if we don't, yeah, this conclusion follows totally. It's very strong. Therefore, it's cogent. Now let's run through a couple more examples. There's one up here that I really like, and I want to give me a second here. Oh, right here. This is a really good example. Okay. So we're on page 51. I'm not sure what page it is in your Mind Tap if you're following along with Mind Tap. Or if you're following along and you're not even taking my class, you're just learning this, we're on page 51 of the 13th edition of Hurley. So unlike validity and invalidity of deductive arguments, the strength and weaknesses of inductive arguments allow for degrees, okay? So this is a really good example. The barrel contains 100 apples. Just imagine a barrel, right? It's got 100 apples in it. 3 apples selected at random were found to be right. Therefore, probably all 100 apples are right. Can you see a problem with that? There's 100 apples. You select 3 that are right. And from that, you conclude that all 100 are probably right. How would you make that stronger? So we know this is weak, that even if these were true, this would not follow. Why? Because you got a really small sample size. You only got 3 apples that you selected at random, right? You need more to conclude this. So here's a better one. This barrel contains 100 apples, the same first premise, right? They alter the second premise and they say, hey, instead of 3, 80 apples selected at random were found to be right. Therefore, probably all 100 apples are right. And what these two examples are getting at, this is weak and this is strong, and it's allowing for degrees. Now I ask you, how could you make this one even stronger than it is now? What would you do? I'll give you a second to think about it. I got a barrel that contains 100 apples. I pick 80 apples, and therefore I'm concluding probably all 100 are right. Now, on its own, this is a good argument, right? It's cogent. If you allow the premise is true, the conclusion follows. How can you make it stronger? Yes. You might be thinking 90 apples or 95 or even 99. And again, you're getting the degrees of probability even higher. So inductive reasoning The bottom line for this is you want the more statistical data you have, the better. I mean, the more the merrier. Let me apply this to a sample drug. You're in college, or you're learning about logic right now, or critical thinking, and you're saying, what if I come along and there's a TV commercial that says, hey, if you take this pill, it will make you smarter. And you're thinking, yeah, man, yeah. What kind of evidence would you want to make you believe that the pill actually worked? So let's say I tested this pill in a classroom of 30 students. 29 students took this pill, and on their next test, they did really, really well. You might say, oh, that's kind of good, right? But it's like 29 students. And then what if I said, let's make it really, really strong? Because remember what I just said, the more statistical data, the better. Now what if I said, there was this pill that was tested in 1,000 colleges around the world at random, and classes over 50 students, and we found millions of students that took this pill did really well in their exam. Therefore, probably when you take this pill, you get smarter. Doesn't that sound like it's more catchier than the previous example when you only test 25 students out of 30 in a class that took it and found results? Now I'm saying thousands of colleges, millions of students. We see commercials like this all the time. Or at least you assume that when a commercial is telling you about a drug or some product or diet, whatever, they're saying, look, this has been tested with hundreds and thousands of people, if not millions. Therefore, we conclude the whole world, like anybody that takes this, should benefit from it. So that's the beauty of inductive reasoning. You want a really good statistical data. And if you have really weak data, then you should be flagging that argument saying, hey, I don't think that conclusion follows, okay? So the barrels example, you can map that onto any example of a drug commercial and say, hey, it's doing the same thing. And then you might be thinking, how many people did they select to test this with? 3, 80? Which one's stronger? 80, right. So the apples compared to the drug commercial. So this kind of leaves you with an afterthought that inductive reasoning is really good with the scientific method. It comes a long way. This is actually how cancer research is done. Let's say somebody in your family has cancer, and then you say, well, what do I do? What drug's the best? And they say, well, we can't really give you an exact answer. That would be like deductive, but we can give you a good probable answer saying, hey, we've tested this radiation therapy or chemotherapy and surgery. We've been doing this for 50 years, and here's what we've seen. Results show that if you have lung cancer and you take this radiation therapy combined with chemo, we have an 88% reduction in your cancer, and usually it goes away. So it's not 100% certain, but it's probable, and they give you years worth of research. And then you have to figure out, well, what's the best treatment? And then you say, well, I don't know. What do you think? And the doctor says, well, I can't make that for you, but I can give you the 2 best types of treatment that you can do. Again, the doctor's giving you inductive reasoning. Okay. So that's pretty much it for this chapter. You can look at this summary right here. But the bottom line, we started in the first part of chapter 1 was statements. They're either true and false. You can use statements. You can group them together. Then you're going to have arguments or non-arguments. If you have arguments, they're going to be deductive or inductive. If they're deductive, they're going to be sound or unsound, valid or invalid. Inductive, they're going to be strong or weak, cogent or uncogent. Okay, so that's the mapping. Do a couple examples here. Number 1, since Moby Dick was written by Shakespeare, and Moby Dick is a science fiction novel, it follows that Shakespeare wrote science fiction novels. Oh, sorry, that's the deductive part. Hold on. Let me go down to the inductive, section 2. So let's do this. Let's do number 2. The ebb and flow of the tides has been occurring every day for millions of years, but nothing lasts forever. Therefore, probably the motion of the tides will die out within a few years. Thinking, what? If you thought what, like something's got to be wrong, you're on the right track. So if the premises were true, the 2, if they were true, would this follow? And it seems like no. The first premise is saying, look, man, something like this has happened for millions of years. And then you say, oh, but nothing lasts forever. Probably this thing will die out in the next few years. That doesn't seem to follow from these premises. You don't go from millions of years of something happening to saying, hey, in the next few years, it's probably going to die. So this is a weak argument, and it's uncogent. It has a true premise. This one is true, and this one's true, right? They happen to both be true. Two true premises, right? But this conclusion just doesn't follow from both of them being true. Therefore, it's weak. Okay? And remember, to have a cogent argument, you have to have true premises and you have to have a strong argument. But it's weak. Therefore, the whole thing is uncogent. Okay? Here's one. People have been listening to rock and roll music for over 100 years. Probably people will still be listening to it from now. If the conclusion was true, would this conclusion follow? Yeah, it seems pretty strong. But there's a problem. The premise is false. People have not been listening to a rock and roll for over 100 years. Hasn't been around that long. So in that sense, you have a false premise. And again, if you have one false premise, the whole thing gets knocked down to uncogent, because cogent arguments require strong and true premises. But this premise is not true, therefore the whole thing's uncogent. Okay, so it's just an example. You can look at a bunch of examples in your homework, or even here, the start, or given to you in the back of the book. Pretty much, though, that should be arming you to be able to do your homework, and that sets you up to be able to conclude this section 1.4. And that's pretty much it. If you have any questions, just let me know. But hopefully the video helps you, and thanks for hanging in there and watching the video. See you next time.